Hi sir, this presentation is for my proposed methodology which I already associated on the report. For the bearing plate, I will use thickness of 25 mm and diameter of 150 mm. This is the minimum prescription of ASTM. I'll use a test tank of 600 mm in length, 600 mm in width, and 600 mm in height. The test tank will be manufactured ahead of time and will be made of wood. The site will be excavated with 6 square holes with same dimension of tank. The soil and geocell will be set up in the box before putting it in the prepared square holes on ground. 400 millimeters of clay will be placed in the box, which will be compacted every 100 millimeters. Optimum moisture content of the soil will be used. Above the clay, 150 millimeters of geocell will be placed. For unreinforced setup, 150 millimeters of clay will be laid. After the preparation, the box will be put on the prepared holes. Plate load test will commence after this. If there is still time, the boxes will be lifted above the hole. The used clay and geocell will be removed from the box. The preparation of test tank will then be set up again right after, and the cycle of testing continues. The proposed site will be in front of the ICE construction lab. The next proposed site will be on a vacant lot near the ICE Geotech lab, though the land here must be thoroughly prepared. For the plate load test, the initial load will be at displacement equal to 1.25 millimeters. The increment of the test is 0.5 kilonewtons for reinforced and 0.1 kilonewtons for unreinforced. And the maximum load or displacement is 8 kilonewtons or 45 millimeter, whichever comes first. With this setup, 16 points on the graph will be made. This is greater than the minimum prescription of ASTM with 6 points. To identify the degree of improvement, the first variable is the bearing capacity. I will use the improvement factor to compare the increase of reinforced compared with the unreinforced. The next variable is the settlement. I will use percentage reduction in settlement to compare the degrees of reinforced compared with the unreinforced. The numerical part of the test, I will use ANSYS as you suggested last time. The first model will use the unreinforced setup. I'll play with the values of modulus of elasticity and Poisson's ratio of the clay to come up with a curve near to the load settlement behavior of the unreinforced setup. The next model will use the reinforced setup. First, I'll use the modulus of elasticity and Poisson's ratio of the clay for the lower part. Then I'll play with the values of modulus of elasticity and Poisson's ratio of the geocell reinforced soil to come up with the curve near to the load settlement behavior of the reinforced setup. With those models, I can compare the behavior of soil. First is with the vertical displacement. Next is I can compare the vertical stress.